I want to show you how you can create your own heavy-duty BLDC controller. In this series of videos, I'll also teach you how to create switch reluctant motor controllers and induction motor controllers for electric vehicle use and also industry use. Today I'm working on the commutation sequence. What I've been doing is to put 3 Hall effect sensors, and I use the 12 volts. It's actually the motor that I was driving in the other video, whereby I was generating power from. Right now I want to create its commutation. The lines in this 3 hole tells me the state, the magnet and the coil interaction. I've realized that in any given magnet, this is the most tricky part to make, trying to create a sequence that will be adopted. Trying to name the 3 terminals. I named one as N1 and N2. The other one, the center one, I named it as P2, and this other end I named it as P1. It was a long process of trying to put together how the sequence will work, and eventually I was able to get it aligned. But trying the full wave and the half wave, I noticed that the half wave is easy to adopt, and also with the work that I wanted to use the motor for, I decided to go with the half wave. So I'll not show all the details of what I did, but for those people who may want to know exactly how you put together this, get to me through info@giro.com. I'm now having the sensor or defect sensor driven by this separate battery. I want to use this Mosfet Z44. Run with this battery. I'll eventually try to add this battery, see if it can increase the speed. And so I put a little push on this. There it is. It's running and it's generating 7 volts, 7.5. Consuming or running at 0.8. Probably this is the slow speed. The battery might be discharged. We can try to increase the speed by taking the whole thing to around 24 volts. I'm using now this small battery since I've connected the positive, the negative of this big battery, and now the positive now becomes the center tap, so that at least I can use the negative to switch the N-channel Mosfet. And now, as I did again, I do a little push, and as you can see now it's running a little bit faster, and the output is of one phase is 7. I think it should be 5 volts because already I've done the rectification. So I'll proceed working on the other 2 phases. By the second phase I'll put it here, and the third phase I'll put it here. And now the current, before I forget, is 0.4 to 0.42 as a maximum that is getting to. And I'm using one Mosfet, this one, whereby it's Z44. This is just for the trial version because I want to put this thing to 400 volts DC. I'll be using these capacitors to make the drives. I want to show you 3 sensors working together. I was thinking of adding this other battery to make it around 30 to 36 volts. First thing that I'll need to do is to put this on 24 volts without connecting this. And so let me commutator and see how it goes. Yeah, it works perfectly. As you can see, all sensors are operating, and the motor is now powerful, and it's running at 0.7 amperes. I've thought of adding the lithium-ion battery to make around 36 volts and see how it goes. Let's switch it on. It's working well and it's powerful, so I'm aiming to run it at 400 volts. Obviously I have to put an upper gate on this line, so at least once I put the diodes, I can now collect the back EMF from the system back to the battery to make the module very efficient. And at the end of the day, this unit should run coupled with a generator, and I'm anticipating that I'll manage to make a 10 to 20 kilowatts out of this thing. I can get all that energy from this. That's what I believe. Let's get in touch sometimes later. On the other hand, ensure that at least you subscribe to my channel, you like my pages, and for those who want to make money in electronics, even if you didn't go to an electronic class, I do electronics coaching, and I'm taking the next class very soon. So make sure that you subscribe, and I'll respond to your inquiries, including if there are questions to do with whatever that I've done today. Thank you.